Hopefully that works and all is good. So thanks, Dave, for the intro. My name is Tim Chase. I'm going to talk for a little bit about CNAPP as it relates to Kubernetes security. Just a little bit about myself. I am the field CISO at Orca Security. So anything kind of your cloud security platform, if you will, is what Orca Security is. My background is I've been in the industry for over 20 years, doing cloud security, container security, application security, being a CISO. That's my background. So, this is kind of right in my wheelhouse. And I was around when Kubernetes was first starting to be really used and containers were first coming mainstream. So what I want to talk about, I'm going to kind of keep it, I think, a little bit simple, but I want to talk, just kind of go back to basics a little bit and just talk about why Kubernetes security is hard. I think a lot of times, we think that Kubernetes security is just runtime security, right? But in reality, there's a lot of different pieces and parts to it that really kind of give you the full breadth of it. And then I want to talk, kind of walk line by line through how we achieve security in Kubernetes, because it really does take kind of an overall platform approach to do true Kubernetes security. And so, when you look at this is kind of a diagram that I created that talks about the different architecture and layers of Kubernetes, right? And the one thing that I want to drive home here is that it's a challenge from uh, the fact that it is complicated. Like we use it to make our life a little bit easier and with being able to create infrastructure, but making sure that you get it set up right and that you get it set up securely can be a little bit difficult because you've got the different parts of Kubernetes. You kind of have that master control plane that runs all of the pieces and parts, right? Where you've got to make sure that your API servers lock down, the people who can actually understand who can actually log in and make changes to the control plane, that's locked down, right? And then you actually have the worker nodes themselves, right? The actual containers. You have security there to kind of understand who can spin up containers, what are the containers doing, are they short-lived, long-lived? Like there's a lot of different pieces and parts there. And then at the end, you kind of also have the different parts of the layers, right? The service accounts that go along with it, secrets management, the policies that go along with it. So when you think about Kubernetes security, it's not just the container itself. There's a lot of different kind of moving parts. And so, when you want to kind of think about it and you're really thinking about Kubernetes security, you need to think about it from the fact that it is workload security, but it's more than just workload security. We need to think about it all the way from dev time through runtime, right? And kind of the entire part, because the earlier that you fix something, the better. And these days, you can actually there's a lot of ways that you can fix it in the IDE, in the pipeline, to make sure that when you don't have any sort of issues when it actually gets to production. And so, what I will say that what I'm seeing these days when I'm talking with customers is that when they're looking for security solutions as a whole, whether it's cloud security, container security, application security, um, um, they're looking for kind of this not point solutions, they're looking for platforms. Because when you're looking at multiple point solutions, you're creating this fragmented visibility, you're creating kind of complexity. And hopefully you'll see that as you go through, that you want something that kind of combines all of this data into one, so you get the entire part of your Kubernetes security in one place. And so this is a way that I wanted to kind of think about Kubernetes security. One is that if you have point tools, if you're doing your Kubernetes security uh, with just three, four, five different tools, then all of your data is going to be in isolation, right? If you're using it if you're running an IAC scanner at runtime, at dev time, and then you have something monitoring your Kubernetes security at runtime, and those pieces of data don't talk, that's a problem. Right. So you really need to understand that Kubernetes security isn't in one place. It's all throughout the development lifecycle. And then having a centralized data store is going to prove to be important. So when you're taking all of this data from your different security tools and you're understanding the different parts and pieces, you need to have a way to store it all in the same place and all together so that you can report on it. If you're in charge of doing security, and you have to find a way to normalize the data from your IAC scanner, your vulnerability scanner, your Kubernetes runtime, your KSPM, and put it all in one place, then that's going to be a problem. And being able to normalize all of that data is going to be extremely difficult. So these are just a few of the pieces that I would say to think about when you're looking at your Kubernetes security posture. So this is a way that I look at it when I start to look at the point tool problem and the different places inside of a Kubernetes lifecycle that you're going to want to have um, tools, right? If you look all the way over to build time, because if you think about it, um, Kubernetes, the advantage of it is that you can build them in code, right? They're not like the physical servers, or you don't have to go in and kind of manually build them. You can build them in code. So the security should really start way back in the build time. And so the different places that you can have security is inside of an image scanner, uh, inside of SAST, secret scanner, IAC scanner. Those are all kind of build time um, Kubernetes tools that you can use, right? And we'll dig into those all a little bit later. And then you kind of get into the deploy time. So when you're getting ready to deploy what you've built, then you have different places where you're going to want to look at security. You've got a policy engine where you're going to be able to set policies of what you want to see from your Kubernetes containers, what's acceptable and what's not. Having that emission controller there. I know that previous folks have been talking a little bit about emission controllers as well, but being able to define kind of what is acceptable and what's not, and being able to fail the builds appropriately, that's a part of it as well. Um, and then so there are several tools that you can use at deploy time. And then getting into runtime, now you're looking at, what kind of runtime security. I need to look for container escape. I need to look for abnormal activity that's happening on the servers itself. Being able to take that, report that into kind of the SIM and understand, look for those pieces and patterns from the cloud control plane, from the container security, and then ultimately take that also into the identity and access management. So um, when you're looking at who has access to the containers, who has access to the secrets, how do you manage that access? And then when you're looking at the containers and trying to understand what permissions that they have. How do you do that, right? And then on top of all of this, we have compliance, right? And I think compliance is one of those things that is mandatory these days, right? We used to take GRC. When I was starting in security, that wasn't really a big deal. And over the years, we've seen it kind of grow into being a bigger part of our security program. But you need to understand the compliance aspect of all of the containers in the Kubernetes. Do you know the last time that um, your passwords were rotated? Do you know the last time that your secrets were rotated? Or do you understand your network policies for all of your containers as far as who can access what, right? So there's a lot of different compliance aspects. And so when you look at all of these pieces together, if you were to approach Kubernetes security kind of as a point solution problem, you can see it's going to be very difficult. And here's another way to look at it as well: the different places and parts across the lifecycle where you can do container security scanning. So let's dig into each of the different parts uh, of what I would consider a platform solution, and how um, they fit into to the Kubernetes security, right? So IAC security. So hopefully, if you're doing Kubernetes and you're doing containers, hopefully you're building them in code like Terraform, CloudFormation, something along those lines. Um, the advantages of being able to scan IAC security is to be able to see these issues early, right? If you're creating some network groups that are overly permissive, um, then you'll be able to find that early on. If you're creating some containers that maybe are vulnerable with some outdated libraries, you can see that early on, right? So you can kind of take these policies that you can create defining what you want to see inside of your Kubernetes containers, and you can set them early and make sure that you can kind of pass or fail them before they even get deployed, right? And uh, find those issues early on. And I would say that even these days, that's where AI is really coming into it, right? Where if you have IAC implemented where you're doing IAC security and there is a vulnerability or there is a misconfiguration, you can you can use AI kind of built into a lot of platforms to suggest fixes, and push PRs that will remediate that for you. So obviously, finding that early is where you want to find it. You also want to be able to do container image scanning. So being able to integrate into the container repositories is another place where Kubernetes security comes in, right? Because you want to be able to look at the repositories, look for those containers that have the outdated vulnerabilities, and be able to scan them. And it's not just about the one-time scanning, right? To look for the vulnerabilities or the insecure deployments. It's kind of being able to integrate with looking at those container images is important so that as you're building them and as new vulnerabilities come out, you can continue to do the image scanning. Um, there are always obviously new vulnerabilities, new 0 days that are coming out. And so you want to be able to automate that. You can also set kind of the guardrails to prevent insecure deployments. So if you want to be able to say you don't want to let any containers that have anything over medium vulnerabilities released and move forward inside of the pipeline, you can set guardrails, and you can do that in several places, including obviously in admission controller. So you want to be able to set those guardrails and prevent insecure deployments from the start by doing that image scanning. Secrets detection, and this is where we see um, a lot of people get bit these days when you look at a lot of the vulnerabilities that have been discovered or a lot of the breaches, right? Um, as we've moved to the cloud and as we do more infrastructure as code and we're building these things in code, sometimes secrets get embedded into the code that you don't mean to, whether that could be an AWS key, a password, something along those lines. They tend to get embedded either on the containers themselves in a file, or they might get embedded in the Terraform itself that's going to build the containers. So as part of kind of the CNAPP solution, when you're looking at how to build and how to do Kubernetes security, you need to be able to do this secrets detection. So being able to scan GitHub or GitLab, Azure DevOps, being able to integrate is super important. You also want to be able to be able to set kind of the secure policies, right, for specific issues that you're going to look for. So if you've got risky builds or anything like that relate to secrets, you want to be able to kind of build that notification in to developers. And then once again, leverage those pre-commit hooks. So stopping things from making it any further in the development pipeline. So if secrets haven't been rotated or there are secrets that are found inside of your code, being able to set those policies to stop the deployment is the ultimate goal here, because you don't want them to go any further. You don't want to deploy Kubernetes containers that have secrets on them that maybe haven't been rotated, or you don't want the secrets there at all, because we obviously know that a lot of times when you're looking at breaches these days, once people kind of they use these secrets to get around all the other IAM controls that you have, right? And if someone manages to compromise your source code and then they get your secrets, then they can use that to kind of um, get into your environment. Cloud to dev. This is another one that I would say is extremely important for us to consider. So, and this is one of those things that um, I would say is one of the best reasons to look for a a CNAPP solution, right? Kind of the one stop shop for your Kubernetes security, not the point solutions, is the ability to connect the data from cloud all the way to development. So one of the best things that you can do is if you find that you have a vulnerable container that is running in production, if you have a Kubernetes instance that maybe has a vulnerable library or a misconfiguration, um, you want to be able to, obviously you want to fix that, but being able to trace that all the way back to the original IAC code that deployed that is extremely important for a couple of reasons. Obviously, you need to know kind of, you don't want it to be deployed again, right? Because the point of IAC code is to be reusable so that your Kubernetes can be, containers can be reused over and over again. So you want to trace that back so that you can fix it and stop future deployments, right? The other advantage is if there's a vulnerability in a Kubernetes container or misconfiguration, and you take that back to the original code, you should be able to trace that back to see where else you're affected, right? If you're looking through your alerts and you see that there's a vulnerable library, that could be like the latest version of the log4j or something. And you're like, oh crap, I got to go back and fix this because this is coming from my baseline container. You need, by having kind of this platform view, you can take that back and go all the way to the code, fix it, do the update so that it doesn't get deployed anymore. But then you should also be able to understand where else you're affected. You can look at this IEC, this Terraform, and say, oh, look, I've actually got 100 other servers that use this same. So let me go ahead and redeploy these other servers, or here are the other servers that I need to fix, right? And so being able to have all of that and being able to trace it back is super important. Um, the next thing that I would say is KSPM. And so being able to understand, are you adhering to the best practices? KSPM isn't as well known as like CSPM. I think a lot of people understand cloud security posture management, but KSPM is Kubernetes security posture management. So if you remember kind of at the very beginning, we were looking at the stack of what makes up Kubernetes and why it's so complex. You kind of do have that control plane aspect. And one of the things that I will tell you is that sometimes being able to get down to that control plane is an attack vector, right? So being able to kind of compromise the Kubernetes administration is a way that you can get in and have access to the other Kubernetes ones. So being able to understand, am I deploying my Kubernetes securely is important. So KSPM allows you to kind of visualize all of your clusters across the major clouds. What I'll say as well is when you're looking at a lot of times we're not just focused on one cloud like Kubernetes and AWS, like AKS, but maybe we're focused on Kubernetes and Azure too. Maybe you kind of have this multi-cloud environment. So you kind of need this way to visualize all of your Kubernetes clusters across your major clouds. I mean, the first step to visibility is the first step to good security is visibility, right? So KSPM helps you get that visibility of all the Kubernetes that you have into one place. And then you can kind of understand all of your Kubernetes risks in one place. Are my hosts configured securely? Do I have any sort of do I have anything that's kind of misconfigured? When you look at a lot of the breaches these days as well, it goes back to misconfiguration. So how common is it that we see things like MFA not turned on um, for any of your administrative functions, right? So things like that can be caught early on. So KSPM helps you kind of look at your overall hosts and containers and images and make sure that you've got that control plane locked down. And then you can kind of easily implement those compliance checks and those guardrails. The next things that I'll say is by having all of this data in one place, by being able to look at the IAC, being able to look at what's happening and how things are configured in runtime, having KSPM and being able to look at those policies, looking at the identity of who can do what in your cloud environment, in your Kubernetes environment, it makes compliance a lot easier. So I think of kind of compliance in a couple of ways. So benchmarks and then overall compliance. So um, when I was running security programs, I wanted to adhere to certain benchmarks. That was kind of my first step when I would go into a greenfield um, security company and start implementing um, Kubernetes and cloud security. I would start with like CIS benchmarks, NIST, something along those lines. So that's typically where I would start. And by being able to monitor all of your Kubernetes in one place and have that visibility across all of your clouds and across your entire um, stack of Kubernetes, then you can do things like being able to understand, do you adhere to the CIS benchmarks? What can I do to adhere to NIST? Being able to look at STIGs. So if you're in government, and you need to adhere to STIGs to do that government work, you can do that as well. And then you can centralize your overall compliance, right? So one of the biggest things that I see when I talk to CISOs these days is obviously, how can I automate compliance? Well, being able to use a CNAPP solution inside of your Kubernetes environment can help you do that. So you can centralize your compliance by having all of this data in one place. If you can visualize having kind of your identity, your all of your the visibility into where all of your Kubernetes is. What do I have running at runtime? What's my code look like? All of this data in one place, it really helps you automate the compliance so that when you have to do your PCI, you can run a report and it will see all of the data, right? Um, and if you have to do SOC 2 or whatever, fits your industry, that's where CNAPP really helps because you're not just um, you're not doing a spreadsheet and having to go manually pull all of this data. You're not taking vulnerability data and then identity data and then posture data and trying to check all of the boxes to make the auditor happy. By using a CNAPP solution, you can actually automate this compliance and give that report to the auditor, which can save obviously a lot of time and money. And then I'll say that the next step of container security here is being able to catch development risks kind of early on, right? So when you look at containers themselves, not just the IEC or the plane, the control plane, and you're looking at actual containers, you can look at it by adding development risks before production. So you can do things like continuous container image scanning, source SCA to look for those outdated libraries, secrets detection. So that's kind of the container security itself that you can really focus on. Um, and then the next part that I would say is being able to prioritize detection and remediation. So by having all of this data um, together, uh, you can say, okay, which are the most highest priorities that I need to detect and remediate? Do I have the critical, the high, and you have all of this data that might tell you this container it has access to this PII data and it's externally exposed, right? And it kind of gives you all of this data that helps you understand what you need to fix first. And that's also one of the biggest problems that I see inside of security teams these days is the prioritization. So CNAPP helps you prioritize by having all this data together. Where are my risky users? What containers do they have access to? What data do they have access to? And that helps you ultimately prioritize the detection and remediation. And then I would say being able to remediate those container risks at the source, right? So being able to go all the way back and do it at the code level as early on, and then create those PRs is super important. Um, and then kind of finally, CWPP, so workload protection. So when you're looking at Kubernetes um, security kind of that's running, what do my containers look like in a production environment? So the first step, obviously, we talked about getting visibility into your cloud workloads across your entire cloud estate. So that's kind of the first step here. And then being able to understand, what is running and what should I fix first? Do I have any malware? Am I seeing any lateral movement? What do I have sensitive data that's subject to risk? By running and understanding kind of what you have running in your environment, it helps you understand all of this and what you should fix first. And then finally, being able to detect unknown and known malware. So when you're thinking about workload protection, CWPP, for Kubernetes, you should think about um, understanding what your workload is doing inside of while it's running. For the most part, I like to say that Kubernetes workloads, containers, they tend to do the same thing day in and day out. It's not like they deviate too much in as far as who they talk to inside of the cloud environment. For the most part, applications have a distinct way of talking. And so one of the ways that you can look at and detect unknown malware or breaches is by understanding when that pattern deviates. When your when your container that always talks to server A and server B starts talking to server C, you might have a problem. So that's one way of being able to look for unknown malware, in addition to kind of the known signature-based malware. And then vulnerability management. So being able to understand where on your containers do you have vulnerabilities. You should be able to prioritize the vulnerabilities based on many factors like external exposure, criticality with CVSS, data they have access to. And the important thing is, by having a CNAPP solution, you can kind of go beyond just a CVSS score by being able to understand more data about the vulnerabilities. Is the library, is the vulnerability actually reachable, or is it just kind of sitting there on your container? Are the cloud assets exposed, or are they internal only? Understanding things like that really help you prioritize and contextually understand what you should fix first. And then finally, being able to kind of streamline remediation with AI-driven options. So being able to have kind of a CNAPP solution that can give you that AI-driven advice. Hey, I'm seeing that you have this vulnerable library. I would suggest updating to this library because this is the next secure one that doesn't have any additional CVSS scores against it. Um, and the one thing that I kind of wanted to drive home here, kind of as the last slide as we wrap up, is this is why CNAPP is obviously so important. By having for Kubernetes security, so you've got this entire kind of foundation of having like this unified data model where you're pulling everything in. You're pulling in the scanning data, the side scanning, your cloud events like your CloudTrail, your CI/CD scans, your network probing. Um, by having all of this data to support your Kubernetes security, it allows you to drive very specific outcomes, like being able to detect and prioritize risks because you have the control plane data. You know what's externally exposed, right? You know if a library is reachable. You can kind of consolidate and remediate the security issues because you're not getting those multiple vulnerabilities from multiple tools, which allows you to obviously help prevent attacks as well. So by being able to understand, uh, fix the issues quicker, it can help you kind of prevent those attacks. And then obviously monitor compliance. So you can kind of monitor your overall Kubernetes compliance by pulling all of this data. And overall, it would help you kind of elevate your security posture by having all of this data in one place. Um, you can, and being able to roll out a security program based on it, it can really kind of help you elevate your security posture. And I know I'm at time now, so I'm happy to take questions, or you can find me in the chat as well.
Awesome. Hey, thanks, Tim. That was awesome. That was a packed presentation. So a ton of stuff in there. We have one quick question. I think we got time for one. You've got, you're right at the end, but the question that came in is based on sort of all the breadth of what you were covering there is, like where do people need to start when they're,
Mhm.
embarking on a Kubernetes security program? Is there like any one best place, or what are your thoughts there?
Yeah, yeah. My thoughts are the same way you would start kind of in a cloud security program. Is just identify what you have. So, before you start on runtime, like runtime is super important, but I always say get your KSPM in place and understand kind of what you have in your environment and get it locked down first. Because if you can't identify it, you can't fix it. So that's always where I start with a security program.
That is some sound wisdom. Good stuff. Well, again,
All
hey,
right,
thanks so much,
thanks.
Tim. And if anybody's got questions for Tim or the team at Orca, please drop them over into our Slack channel. So again, fantastic stuff.